Hello, my dear students. Hope all of you are fine. Okay, so today I came up with a very important lecture. Okay, and today we are going to discuss that in organic chemistry, okay, how to write an open chain structure and to convert it into condensed formula, and finally how to change that condensed formula into a bond line formula or bond line form. So this lecture, obviously it is a basic of general organic chemistry and it's required for all the students who are dealing with the organic chemistry. Okay, so let's start the class. First I will teach you how to write the open chain structure. Okay, and we will discuss one by one how to convert that open chain structure into condensed formula or condensed form, and finally how to change that condensed form into bond line form. So we will discuss the rules through different examples. Okay, now first of all, what is a open chain? Open chain means, see, I am writing the three form. Okay, suppose I am taking an example. Say I have written simply, yes. Now in the open chain form, what we show all the bonds, right? We show all the bonds. Clear? Whatever the sigma bond, pi bond, or you say single bond, we show all the bond. Okay. So this is a skeleton structure where I will show all the bond. Now you know that carbon is having valency, tetravalency, right? 4 valency. So what we will show in the open chain structure, we show all these 4 bonds like this. Okay, so 1 2 3 4, 1 2 3 4, 1 2 3 4, right? This is open chain form. This form is known as open chain form, and we write hydrogen here. Okay, so in the open chain form, my dear students, we write the formula in such a way that all the bonds are visible. Clear, all of you? So that is the open chain form. So I am writing open chain form. Clear all? Now if I have to write it in the condensed form, if I have to write it condensed form, if I have to make much shorter, okay, now condensed form is writing is more convenient than the open chain form. Why? It takes less time, right? So in condensed form, what we do, we don't show the bond of this hydrogen. Okay, we only show the bonding in between the carbon, but we don't show the bonding of this hydrogen. Clear, all of you? Okay, so that is the condensed form. We are making the structure much more condensed. Yes. So what I shall do? In that case, I will write C. Okay, C. I'll leave little gap and write C. The same form I am converting. See how I am converting it. Okay. So how many hydrogens are there? 1, 2, 3. So I will write CH3. Got? How many hydrogen is here? 2. So I will write H2. Okay. How many hydrogen is here? 3. So I will write H3. So this is your condensed form. Okay. So I am writing condensed form. Clear, all of you? Okay. So this is how I have converted this open chain form into condensed form. Clear? Okay. Now, if I don't have time and I have to write it in much shorter form, so the best method is to represent it in a bond line form. Yes. So the best method is to write it in the bond line form. Now, how to convert it in the bond line? Okay. Now the name only says bond line, mean where we will show only that bond line. We will not show any carbon over there. Okay, neither we will show any carbon nor we are going to show any hydrogen part. Okay, so that is very important. Now in bond line, okay, suppose I am drawing a line like this. Okay, I am drawing a line like this. In bond line, every point of the vertices, okay, every point of this line it shows a carbon. I mean, this is the vertices, this is another vertices, and this is a bending part. Okay, so all these points shows the carbon. I mean, here you have one carbon, here you have to show one carbon, here we have one more carbon, but we will not write that carbon. Instead of that, what we will do, we will only simply represent it. How many carbon are there? 1 2 3 carbon are there. So I will simply give dot like this. Okay, in the zigzag pattern I have given 3 dot for 3 carbon, and I will join them like this. Yes, so every point of this, it shows that it is a carbon. Interestingly, we do not show any hydrogen over here in the bond line structure. By default, you have to consider that hydrogen is there. I mean, you have to consider that hydrogen is there, but we don't show hydrogen in the bond line structure. Okay, so all the vertices point or the intersection point, wherever you see intersection, I will take more example. Wait. Okay, so all those points shows what? Carbon. Clear all of you? So here you can see how I have converted propane. So here I have taken the example of propane, meet, eat, prop. So you can see that the open chain structure is take little more time to write. It's a time consuming part. So during the examinations or when we are in a hurry, we used to write condensed formula, and the best method is to write the bond line formula, because you can see in bond line formula no need to write of this hydrogen, right? But yes, in the bond line formula there are few things you need to note. Now what are those things? While writing the bond line formula, if we have double bond or triple bond, we have to mention. Okay, if the functional group like OOH, OH, okay, or any other atoms are related, say nitrogen, sulfur, then we need to, or oxygen, then we need to mention them, okay, separately with this structure. We need to include them or add them in this structure. I'll show you. Okay, so this is the first thing. Okay, I hope you got a little idea that what you have to do is that writing the bond line mean you just count the number of carbon and give dot and join that dot in that zigzag way. So every vertices of the point will give you what? Will give you carbon. Clear all of you? Okay, let's take another example. Okay, let's take another example for better understanding. Suppose you got a compound like this. Okay, now this time I have added one more carbon here. Now what is this structure? Okay, this is an open chain structure. So I will first write in the open chain structure. I have to mention, you can see it's take time, isn't it? So it's not very convenient to write, but yes, in the primary level, if you are in class 10, then we start with this only. Okay, now this is an open chain structure. So I'm writing here open chain structure, OCS. Okay, now if I have to convert it into condensed formula, how shall I do it? So the first thing is that you have to write the carbon. 1 2 3 carbons are here, so I have written 3 carbon, and one more carbon is given here. You can see C. Okay, so what shall I do with that? I am showing you. Let us start from this carbon. See, this carbon is having 3 hydrogens, so I will write 3 simply. Clear? Now this carbon is having 3 carbon. I will write 3. But what to do with this carbon? It is having 1 hydrogen, yes, and one more CH3 group is also given. So what you can do is that you write that CH3 group in a bracket and join it like this. Okay, clear all of you? Okay, so what we can do is that CH3 and then, but sometimes you see in the book it can be given also like this, that CH3, CH3 and then finally CH3. So both are same. Okay, both are same. So if the structure is given like this, that a methyl group or a substituent part is or a branch you are getting, then in that case we are going to make the formula like this. So what is the advantage? Advantage is that we need not to show the bonding of the hydrogen part. Okay, simply you are writing. Now another format. Now how can we convert this into bond line? Yes. Now how many carbon are there? 1, 2, 3, 4. 4 carbon are there. But wait, how many carbon are there in the longest chain? 3 carbon. Okay, so let's start with that. 1, 2, 3. So I'll give in a zigzag pattern in the bond line. 1, 2, 3. Okay, so let me write that this is a condensed formula you have write. Okay, this is a condensed form you have written. Okay, now 1, 2, 3. See, 1, 2, 3. I have joined this. Okay, so this shows that this is a propane. Clear? But in the middle carbon, we have another carbon attached with it as a substituent. So what shall I do? How many carbon is there? 1 carbon. So I will give one dot here. Okay, and simply I will join that. Yes. So this becomes the structure or the bond line formula of this compound. Getting? Okay. So it's very easy, isn't it? Need not to write the hydrogen. Okay. And need not to show any other thing also. Only simply representing it with a bond line. So this is the most convenient way to write. So these structure shows or gives the or represent what? You can see. Now if you write the name, what will be the name of this compound? 1, 2, 3. Yes. So we'll write 2-methyl methate prop. So we'll write propane. Yes, 2-methyl propane. So all these structures resembles also 2-methyl propane. Okay, getting idea? Yes. Isn't it easy, my dear student, to write the bond line structure? Now after watching this video, you will completely know how to write the all type of formulas in the organic chemistry. Okay, general organic chemistry. Okay, now suppose another compound I am giving you. Okay, let's try with this also. Yes. Okay, now I have given you this type of compound. Okay, how to write this? So first thing is that this is an open chain structure. So what you can do is that you have to write it, all the hydrogen you will give like this. Okay, the first thing is that count and give the hydrogen. So you can see that it is taking time, isn't it? So it's not convenient to write, and that is the reason we go for, and sometimes what happens, possibilities that you can miss also 1 or 2 hydrogen. Okay, so first thing is that you have to count the hydrogen, and you see, okay, it's so crowdy, it is looking like that. Okay, so this is an open chain structure of this, so we have to count the bonding. Okay, so each carbon we have shown with all the hydrogen bonding and whatever the bonding is given. Okay, all the bonding you have represented here. So this is an open chain structure. Okay, open chain structure. Right, now I have to convert it into the condensed formula. So what shall I do? Okay, 1, 2, 3, 4, 5, 6. Okay, so first simply copy like that. 1, 2, 3, 4, 5, 6, 7. Okay, like that. Okay, so I have given it like that. Now what shall I do? How to write this condensed formula, isn't it? Right? Okay, so here you can write hydrogen CH3 CH2. Okay, CH3 CH2 CH3. Here all the bonds are filled. CH3 CH2. So this becomes the condensed formula for this compound. Isn't it easy conversion? Isn't it easy? Okay, simply write that CH2 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 form. Okay, do not show the hydrogen part. Clear? Don't show the hydrogen bonding over here. So that becomes a condensed formula. Now the main thing is how to convert it into a what? Bond line structure. Yes. For that, you first need to know which is the longest chain. Right. Now, meth prop but pen, isn't it? This is the longest chain, or shall I take meth 1, 2, 3, 4 or 1, 2, 3, 4, 5? Which is the longest chain? Okay. So first thing is that you need to select the longest chain. Yes. So let us select this as the longest chain. I am selecting this as the longest chain. Clear all of you? Okay. So once you select the longest chain, then count the number of carbon 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. See, I have given 5 dot over here. Okay. Once you have counted the longest chain, you have to give the dot 1, 2, 3, 4, 5. Okay. So 5 dot I have given. Clear all of you? Okay. Now join this line. Okay. So we will join this line. Clear all? Now after joining, you see that where are the branches you are getting? Okay, in which position? Now suppose 1, 2, 3. You see from this position the third carbon. 1, 2, 3. So this represents the third carbon. Okay, this represents the third carbon, or if I come from this side also 1, 2, 3, third carbon. So this third carbon is having one methyl group. You can see one methyl group. So I will put a dot over here. Okay, it shows this methyl group. You see, for methyl group only one carbon, one dot. Okay, and then join that. Clear? Now what shall I, how to write this ethyl group? See, in this ethyl group, two carbons are there. So how many dot is required? Yes, 2 dot, but you have to show it in a zigzag way. So one dot and another dot I am giving. So and then finally I will join them. Okay, and finally I want to join them. Okay, I am teaching you with the dot, but you can also write it simply like that. See, without giving dot also you can do same thing. Now since I am teaching you, so I am using the dot over here. Once you learn it, then you also start writing this dot. Okay, so understood all of you? Okay, getting the idea how to write? Yes, it's becoming easy now. Okay, so you can see this is very easy to write. Okay, so this represents the same structure, the same formula. Okay, only the difference is that here we are not showing any carbon. You can see we are not showing any carbon, simply the bonding we are showing it. Okay, so no hydrogen bonding, nothing. So it's very easy, isn't it? And not take time also. So this is your bond line structure. Clear all of you? Okay. Next, let's take another example. Now, say if any double bond or triple bond is given, then how shall we convert? Okay, suppose I have given you a compound like this, a double bond is given here. Okay, then how to write the open chain structure? So 1, 2, 3, 4. Yes, then here 1, 2, 3, 4, count 1, 2, 3, 4, 1, 2, 3 and finally 4 here. Clear? Okay. Now how to complete? So this is the open chain structure. This is open chain structure. Clear all of you? Okay. So here I have shown all the bonding. Okay. And now you have to convert it into the condensed. So pause the video and start doing it by yourself. Try it. So how many carbon are there? 1, 2, 3, 4. So 1, 2, 3 and finally 4 you say. Now how many hydrogen is here? 3 hydrogen. So simply write 3. How many hydrogen is here? Yes, 2. Only 1 hydrogen is here. How many double bond is here? Yes. So I have to represent it with a double bond. Clear? And how many hydrogen is here? H and finally H3. Okay. So sometimes it is, you will see that in the book either it is given in this format or sometimes they also give it in this format also, where they do not show this bonding also. Okay, so this is also another form of the condensed form, right? So if you get either it in this form or this form, both are in the condensed form only, where we are not showing the bonding. Okay, it shows the same thing. Understood? Okay, clear? Now how to convert this into bond line? Now how many carbon are there? 1, 2, 3, 4. So give 4 dot in the zigzag way. Okay, and then join them. Right? Now count from any one side. So 1, 2, 3, 4. Right? So you can see in the second position double bond is there. So with the second carbon double bond is there. So 1, 2. So I'll give the double bond over here. Okay? I'll give the double bond over here. Over. Isn't it easy? Isn't it very easy? Write in the comment section. Okay, so which is more easy? This is a very time, it will not take much time, but this is a time consuming. Okay, so once you learn the bond line structure, isn't it very easy for you to write any compound? Okay, so this is another pattern which I have taught you. Now let's move on to some complicated one and see how to write their bond line structure. Not complicated, nothing is complicated. Okay, everything is easy, take it easy. Suppose a functional group is given, OH is given. Excuse me. How to do this? Yes, so in the bond line, first in the open chain structure we will start with. So where I will write all the hydrogen. Now you have learned, my dear students, that how to write the open chain structure. Yes, so this is the open chain structure. Open chain structure. Okay, now convert it into the condensed formula. 1. Okay, let me first write the carbon. 1, 2, 3. Yes, simply H3, H2, H2, OH. So this is the condensed formula. So here this is the condensed form. Yeah, condensed formula. Clear all of you? Now how to write the bond line for this? How many carbon are there? 1, 2, 3. So write 1, 2, 3. Give 3 dot. Okay, 1, 2, 3 in the zigzag pattern. Clear? And then join them. Okay. Now after joining, you see OH is given in the first position, in the first carbon. So first select, you first decide from which side you are going to take first carbon. So if it is attached to this carbon, so which mean here I will show it with a bond dash OH. You know oxygen has a double bond, it is having 2 bond, okay, divalent. So yes, this bond you need to show. See, this is the bond. Okay, this bond is linked with the carbon and OH. Understood? Okay, so that was I was telling that if any functional group is given or any group is given, in that case you need to show them with a bond. Clear all? Okay. Next, let's try with another example to make your understanding crystal water clear. Okay, let's try with this. How to write this? OH. Yes. Now pause the video and quickly practice or write. So here for the open chain, okay, here this, oh my god, it's taking too much time. Okay, and making the video lengthy also. So open chain structure, it takes time. Okay, now what is this, my dear student? You can see here one functional group is given. COOH is a, what does it represent? Acid, carboxylic acid. Okay, so 1, 2, 3, 4, right? So how to convert it into condensed form? 1, 2, 3, 4. So CH3 from this part, H2, H2 and OOH. So this is the condensed form of this. Now how to write the bond line? How many carbon is there in the long chain? 1, 2, 3, 4. See, 4 carbon are there in the long chain. 1, 2, 3, 4. So 4 dot 1, 2, 3, 4. 4 dot are there. Clear? Join this 4 dot. Yes. After joining, now you see I have to mention this OOH. Simply write OOH. That's it. Done. Over. Isn't it very easy? Okay. So this is your open chain structure. This is your condensed form. And this is your bond line form. Which is more easy? Write in the comment section. Okay. If you are watching till here, then write in the comment section. Okay. So isn't it this very easy to write? Okay. I will show you few more examples because everything is not over here. You have to learn few more patterns also. Okay. See, if I give this is the ketone, right? Ketone I have given. So open chain structure, yes. And if you do not know how to name the compound, already I have prepared IUPAC nomenclature lecture. you can go through it. So 1 2 3. So this is a open chain structure. Okay, finally you have to convert it into condensed form. C, then CH3. See, I have condensed it, double bond O, CH3. So this is the condensed form. Clear all of you? Now change it into bond line. Try it by yourself. How many carbon are there? 1 2 3 in the longest chain. 1 2 3. So first select the longest chain, and that is the first thing you need to do before you step on to the bond line. Be careful. Okay, so 3 carbons are there, so 3 vertices, 1 2 3 3 vertices also I am getting here. Okay, now with the middle carbon, middle one, you see oxygen is there, so you can simply write O. Okay, so this represent the same compound. So this is your bond line structure. Clear all of you? Getting idea? Understood? Okay, chalo, let's discuss one more, and then finally I will end the video or the lecture for today. See, if it is given like this, how to name? Not how to name, how to write the bond line. Okay, so start doing it by yourself. Okay, yes, start doing it by yourself. So pause the video over here and start doing it by yourself. And if you can do it by yourself, if you have done it by yourself, also please write in the comment section that was it helpful to you or not. Okay, done. So first, oh my god, again it will take time. You have to complete the hydrogen part. Okay, you have to complete the hydrogen part. Okay, half of you have, I think you have gone to sleep. Wait to complete this part. So this is so hocho pocho. Okay, so that is why you see it's taking time, isn't it? So this is the open chain structure. Open chain structure. Now how to convert it into the condensed form? So let's first sort it out. 1 2 3 4. My goodness, see from where it is connected. Here with this bond I have connected, right? So 1 2 3. So let me make it short. 1 2 3 4 5, and then 1 carbon I have given here. 2 more carbon I think I have given over here. 1 carbon I have given here, and 2 more carbon I have given here. So you can see writing bond line open chain structure is very confusing one. You can see the structure. Okay, you may anytime you may do a mistake over there. So it's try to avoid writing open chain structure, but yes, in the primary level I am telling you we follow this thing. Till class 10 primary level you follow this thing. Okay, but if you are a senior student 11 12, okay, try to avoid writing the open chain structure. Now here I have to condense it. So what I will do, CH3 H2 H3 H3 H2 H3 H3 H2 H3. This is your condensed formula. Okay, at least it look better than the open chain structure, right? Condense or the skeleton structure. Skeleton structure mean where you write only C. This is known as the skeleton structure. Okay, so here this is your condensed form. Okay, finally, yes. Now pause the video and write the bond line. What you have to do? You have to select the longest chain. So let us find the longest chain. 1 2 3 4 5 6. 1 2 buckle my shoe. 3 4 knock at the door. Oh my god, what I am doing? 1 2 3 4 5 6. 1 2 3 4 5 6. 1 2 3 4. Okay, so I am taking the simplest one without wasting much more of time. Yes, so this is your longest chain. Okay, now in the longest chain how many carbon you are getting? 1 2 3 4 5 6. So let take the 6th dot. Okay, So I'll take 6 dot 1, 2, 3, 4, 5 and 6, okay, for the longest chain, and immediately join them, join all the vertices. Okay, so 1, 2, 3, 4, 5, 6 you have joined. Now immediately after joining, do the numbering. Okay, do the numbering. Suppose 1, 2, 3, if this is my third carbon, say this is my third carbon, 1, 2, 3, then in the third carbon you see one methyl group is there, so I'll give one dot over here and I will join it. Okay, see here ethyl group is there. Now in the ethyl group there are 2 carbon, so you have to join like that, 2 dot you have to make in a zigzag way. Okay, and then you have to join. Clear all of you? See here in the fourth carbon, 1, 2, 3, 4. Okay, here you have to draw. Yes, you have to join here. Now this is the third carbon, 1, 2, 3. Now this is the fourth carbon. See, with the fourth carbon, two more methyl group are there. So I'll write one here, a dot, and another for this, and a dot. Clear all of you? Okay. So this is the bond line structure for this compound. Clear all of you? Okay. So I hope you learn how to write the bond line structure, how to convert the open chain structure into condensed form and condensed form to bond line structure. Yes? So which is more easier? Write in the comment section writing which formula is very easier. Okay, so thank you for watching the video. Stay safe, stay healthy, and once again thanks for watching. Bye bye.